Hi, good day. Today we are going to look at web APIs in Go. As usual, we'll build a simple web API in ASP.NET and then we will convert it to Go. I'm using the ASP.NET 6 template to create a minimalistic web API. So if you look at the program.cs, it's literally 4 lines of code, or 5 lines of code if you count it correctly. And I'll remove the Swagger stuff for now. We are not going to look at Swagger in this example. It pretty much basically creates a web application and sets up the controllers and run it. In ASP.NET 6, you can technically map the controllers in the main program.cs, but if you want to keep it clean, you might want to do it in a separate file. So we have a controllers file separately, and also we have the the weather forecast model. So it's pretty basically the same as the default template project you get when you do .NET New Web API. I've made some slight modifications, so it's basically setting up some test data, and I've added a get controller which gives you all the weather forecasts, and then for a given date you get a weather forecast, and then you're able to add a weather forecast to an HTTP post. So we get an example of how to do an HTTP get, with a with a route and HTTP post. So it covers a lot of the main use cases we would see on a normal web API project. And the weather forecast project model itself is pretty simple. I kept the data string because I didn't want to do the conversions between string and date, and let's just to keep it simple. That's pretty much it. So let's run this one. .NET run, and we will use Postman to see how it goes. And let's copy the URL and go to Postman and run weather. So that's the controller name, and there you go. So you get the list of weather for all the weathers, and you are able to do get for a particular day. So the route would be like this. Not that. Okay, 10:29. Yeah, let's change it to 30 because I don't think we have 29. Okay, so here you go. And if you want to do a post, create a new weather, you would copy that, make it a post, and in the body, raw, JSON, and let's paste the template, and let's create the weather forecast for the 29th, and we say warm. Um, and we don't need to set the Fahrenheit, that gets calculated, and we will say 23. Nice. And post that, and now if we do for the 29th, actually I put it in the wrong path, so we post that, and now if you query the 29th, we don't, yeah, we need to do an HTTP get. So here you go. So basically a get all, get by date, and post. So simple. And yeah, I quite like the .NET 6 project template. It keeps everything clean and there is no magic. You know what's happening. If you want to set up something, this is where you do it. Um, I know there's a bit controversial, the Web API minimalistic framework, but I think that's quite the right idea. And you will see when we do the Golang where this ideas are coming from, because there is quite a bit of pressure on the .NET framework by competing languages and framework who are a lot simpler, who are a lot cleaner. And for new developers, you're not going to get new developers in .NET if the templates are complex and all over the place. Okay, let's see how we do it in Golang. Okay, so Golang, as usual, we start with a blank. So okay, So the first thing first, Golang has, there is no one way to build web APIs in Golang. It's not built into the Golang language itself. The Golang, like C Sharp, it's just a language, and there is no official ASP.NET um, framework or equivalent in Golang. So what that means is you have a lot of competing frameworks, and we basically have to pick one which you prefer. So for this example, we are going to use Gorilla MUX, and it's one of the more popular frameworks. The other ones are Jin, there's Echo, there's a few of them. You probably pick one of the popular ones to start with and then play with it and figure out which one you feel more comfortable with. Some might be better to your scenario than the other, but let's just use Gorilla Mask because that's pretty much one of the more popular ones, and let's go with it for now. Okay, first things first. So we need to include Gorilla into our application. So let's initialize our mod. Go mod init, and so now let's say go get uh, Gorilla Mask. That's the GitHub repo we are gonna use. So get that, and let's do go mod tidy to clean up our mod file. So what that would have done, you will see, is it created a mod file with a reference to the our project, and we can start using. So once we start using Gorilla Mask, we should be able to see it appear. So let's do that. Okay, so the first things first, you need to create a router. So in that's pretty much what we are doing in .NET, setting up controllers. And so set up a router is, so we say router colon equals to and mask dot, so we have to include the package, and mask dot new router. And what am I getting? So let's do a go get again. Okay, here we go. Okay, so now we got a router, and then we can add our handlers to it. Okay, let's first, before we can do that, we need to set up our model, which we are going to use to uh, manipulate weather, right? So let's create a struct for our weather type. Let's do all in a single file, and then we can clean it up later. So let's do type weather forecast. It will be a struct in Golang, and then we're going to have a date. Like I said, we're going to keep it string to keep it simple for this one purposes. And let's do a temperature C, copy that, and int, and temperature ref, also int, and summary will be a string. As usual, head over to my GitHub repo to look at the source in a bit more detail. Okay, so we got the struct. And so here in the .NET, we have a setter to do this. So this is not really it doesn't have a setter. So this is basically a property on the Celsius. So let's do the same thing in Golang, but Golang does not have the concept of getters and setters. So you have to create them as methods over the struct. So to do a setter for the temperature ref, let's create a function. So we say func, and we do that over the weather forecast struct. So it'll be W, then star weather forecast, and then we can say have a setup. So the general practice is to use set prefix and then the field name, and we don't not taking anything. And what we'll do is we will create the property. So I'm just going to copy the property I've saved in my template in my just to save time, and here you go. So basically we have a setter for the Fahrenheit, which sets the value of the Fahrenheit based on the Celsius, and we can call this setter when we need to set the Fahrenheit. And Go does not have constructors so as like a language feature for struct. So, but in some instances, you might want to have helper methods to create an instance of your struct, because in scenarios where we need to do something in addition to creating the actual instance itself. This is a pretty good example. So whenever we create an instance of weather forecast, we want to set this. It's not going to be cleaner if the client which is using the struct, it needs to do it as two steps. So let's create a helper method to create an instance of a new weather forecast. So to do that, that's another function. So func new, then we can say date, and which will be the string, temperature C would be an int, and lowercase t, and summary would be a string. And we will new it up. So let's say w colon equals to a new of a weather forecast. And so now we need to set the date. So w dot date is whatever is passed in. W dot temperature colon equals to no, date, and temperature C. I might be making mistakes here. Let me see. Temperature C equals to this, and w dot summary equals to summary. So what's missing is the Fahrenheit. So let's set that as well. So w dot temperature dot Fahrenheit equals to set. So we can call the w dot set temperature and thing, and we need to use okay, that's it. We don't have to set it. It's not a. We don't have to assign that. So basically, we call the method which will set it. That's pretty much it. So every time we need to create an instance of weather, we will just need to call this method func, and then that will give us an instance of weather forecast. Pretty neat. Okay, so we got that, and let's create some sample data. So in our controller, we created the sample data by setting up a dictionary. So we have a dictionary of weather forecast, and let's do the same thing. In Golang, an equivalent of a dictionary is a map, which is basically, as the name described, is it's basically a map, and you can have a key value pass on it. So let's create a dictionary for our sample data. So var forecast weather forecast would be a map, and it's going to be based on a string key, so very similar to what we do. So we use the date as the we use the date as the key and the object as the value. So the date will be we are going to use date as a string. So date, and then the struct would be the value. So that's the syntax for initializing a map with a string key and weather forecast as the value. So we will equal to, and we will use the make method to give us an instance of that. So it should be the same make, and let's copy that. What make does is it creates a so it builds an it's a built-in function which allocates and initializes the object of this type. And so now we have a weather forecast where we can create some sample data. So let's create a func to do that for us. So func set up mock data, and so we like we have here, we're gonna pretty much, I'll just copy that here, and I'm gonna change the syntax. Let's just save time. So here in Golang, instead of doing var, we basically have summaries. Colon equals to an array of string, and the parenthesis needs to start on the same line as the definition, and that's that's our Golang array. And I'm gonna make this slightly bigger. And why don't we like it? Yeah, here you go. Braces needs to be in certain places in Golang, so it's mandatory the braces are in starting at the same spot and ends it here. Okay. Now, so we will do a for loop on top of this. So for let's create a value, maybe 6 instances of the weather, and let's say, so to create a weather we need the date, a temperature, and a summary. So let's say date d equals to create a time instance in Golang, you need to use the time package. So time dot now gives you the current date time, and we will add a date. So add date takes in a year, month, or day. So here we'll say 0 years, 0 month, and 1 day. So, and then format. So we're going to create forecast for the next 6 days. And format method takes a string template. So the string templates for date in Golang are based on a 2006 date, and so we basically say 2006, and 01 is the month, and 02 is the date. So Golang knows it needs to format this date in this format, and that's the template in Golang. In C# we do YYY MMDD, but in Golang they actually have an example date, and you just need to put in that, use that example date as the pattern to say what format you want. And I suspect they use this particular example date because the numbers don't duplicate each other. So it's clear when you say 01, it means the month, and 02 means the day. That's pretty interesting. Now we do the Celsius. We are gonna, to do the Celsius, we are gonna get a random number. So in C# we just basically we have a built-in random thing, and Golang does have a random thing. So we just write a small func to get a random number. So func get random temp, and it returns an int. So we want a min of maybe 20 and minus 20. I think that's what we did in .NET. And max maybe 55. 55 is really hot. And return. We use the rand package. So rand dot int n, and we provide the max minus min and plus max. So I'm not going to go into the formula itself, but it just gives you the random number between those particular values. So rand dot int n max minus min dot. Okay, why doesn't it like it? Okay, let's see. I think it's because we are, let's call it, and int, maybe it doesn't. Okay, I thought it was int n max minus min plus min. What package? math.rand. It didn't bring in the package, that's why. So this is based on it picked the crypto. We didn't want this package, we wanted the math package. So that's why my signature wasn't matching up. So we are going to use the math.rand package. So that should give us, so yeah, good here. Okay, cool. So yeah, so just to recap, what happened was when I just played rand, VS Code picked up the crypto package instead of the math package. So okay, so now we got the date, we got the Celsius, and what else do we need? We need the summary. So summary is going to be summaries, and we're going to pick one from the array. So we will use the whatever the current index is. Okay, so now we need to create an instance of the weather, so forecast. So let's create that. So weather forecast column equals to, so we have the, remember we had this new func, so let's use that new, and we're gonna pass in date, Celsius, and summary. So that will be date, Celsius, and summary. Okay, and for some reason I think it says too many values. I suspect maybe it's because it doesn't like the word new. So let's actually say new weather forecast. Date, summary, okay, let's do, okay, let's see what happens next. So let's assign that value to the dictionary of so we're going to say date is our key, and we're going to say assign it the reference of this here. Okay, so we still have an issue here. Is no value used as a value compiler, too many values. So what did we do? We created a func, and which returns, we didn't specify the return type. That's our problem. We should have specified the return type, and because it returns, okay, so the name itself wasn't the problem. So it returns a reference to the weather forecast, and we have to return W. Okay, that was our issue, and so we don't need that. Okay, let's fix that. Okay, so now we are setting up the mock data. We are putting in some instances of the weather forecast, setting it up in our map, and okay, now we can get back to our router itself. So to add a route in Golang, you need to add the handlers. So let's do the handlers. So router dot handle func is the thing what we want to do. And what do you want to do? So you want to say handle the route, which we'll use to return all the weather forecasts for that endpoint. So to do that, so we need to create a handler. So that is going to be another method. So to do that, so let's create a method for that. Func. So this is going to give us all the get all. So let's call this a func get all handler. So handler, and then it takes in a couple of things. So one is the response, and the other one is the request. So it takes in a w http dot response writer, and the second one, it takes in a reference to http transport dot request. So we get all the requests like query strings and what gets posted to the endpoint through the request, and we can write what we want to send out back in the response. So this signature is going to be the same for all our handlers. And here in this particular use case, we don't get any query string or any route from the request itself. So all we need to do is write out our response. So the first thing we will do is we need to set the header. So w.header and .set, and we can say content dash type, and you can say application /JSON, and then you are able to so we need to provide the list of the weather forecast back to the endpoint. So to do that, let's prepare a list. So we need a list of the weather forecast, and we can say let's create an array. There's no direct way to convert from a dictionary to an array list of just the weather. So we'll create temporary create an array, and then we will send it down the wire. So let's make an array of weather forecast, and it starts with 0, and it has the length of the weather forecast. So that's our dictionary. And so we are initializing a dictionary with this type and up with this length. So it creates a size of whatever the length of the weather forecast. Okay, and now let's assign values to the array. So to do that, let's create a for and underscore. We don't need the initial value, and we say value is range over weather forecast, and we can say list and append items to the list, and we are going to append value. So that's pretty much it. So we got the list, and JSON dot new encoder, and we use our writer, which is our response writer, and then we encode at a list, and that's pretty much it. So we set the value in the right response. If these things seem a bit complicated for the simple use case, you are right, but we are basically using the default functionalities in the Golang language itself. I'm pretty sure you can bring in some other packages which makes it easier to do these things, but for the purposes of the example, I'm just trying to use the base language as much as possible and not bring in additional libraries for this example. Yeah, please. Okay, so that's it. So we got our get all handler, and now we can assign it to our route. So we have where's our route? So here. So we got that's our. So if you look at the signature of that, the first one is the path, and then the second one is our handler. So we need to assign our handler, get all handler, and it's going to be method, not this one, and we have to say what method. I think by default it's an HTTP get, but it's good to be clear. So method HTTP dot get, HTTP dot method get. So that's pretty much it. We have pretty much have done our we created a controller, we created a handler, get all handler, we set up some sample data, and that's pretty much it. Why do I get a yellow squiggly line? We saying we haven't set the random temp. We created we are not calling set mock data anywhere. So the yellow squiggly line is really helpful. So let's just do it as the very first step. And the yellow squiggly lines should disappear. So I think we are good. So just to be sure, let's just do a go build. If you do a go build dot, it's going to use on the current path as your initializing folder. So go build seems to be fine. So go run, and let's see how it goes. Actually, we missed a step. So let's go back to the main method. So we have set up the router. We are saying router to handle this, but we haven't really started the HTTP server. So to start the HTTP server, let's say HTTP dot listen and serve, and we are going. Let's say we will do it in port. Let's create a variable for port 8080. So it's going to be at port 8080, and we can do string interpolation there. So let's leave it for now, router, and then let's keep it simple. So we're going to listen there. So let's put a print line just so we know it's waiting to receive requests. fmt.println, and we can say http listening at port localhost 8080. Okay, let's try again. Okay, so now it blocks the program from finishing and waits here. So let's see if this worked. Let's go back to Postman. Let's create a new tab, paste it. It's a get. We don't really need any additional things. Here you go. We get only one. I was expecting to see 6. So let's see what we did wrong. But we did get the response back. So we have to check in our mock data. Um, let's do FMT. So we are setting up the mock data, and I suspect it's a issue in our get handler. So append range over weather forecast, and it's adding a list. What did we miss? What did we miss? Let's do some printlns just to see where we are missing to add the other thing. So let's say fmt.print ln, and we'll see what the weather forecast looks like after we finish with the mock data. So let's start this again. And when we finished with the mock data, it's only adding one item. So there is an issue with our setup of the mock. We are ranging over 0 to 6. We are adding the date. We are setting the weather forecast to setting a new instance of the weather. We are setting the weather forecast. D. We hard coded to 1 day. It has to be, so it's really pretty much writing it again and again. So that was the issue. So I'm gonna get rid of the print line. And when I say we, I mean I made a mistake by hard coding 1, so I intended to add the next 6 days, so it needs to be I. So let's D. Okay, now if I do this again, here you go. We got the list of weather forecast for the next 6 days, I think. So here you got that's the handler. So what did we do? What else do we have in our .NET code? So we did the first one. Now let's do for a given date. So for a given date, let's go back to our main method and set up a second handler. So here we are going to say, I just cut and paste that, and then we say for a given date. So that's our route. And instead of get all handler, we will create a handler for a given date. And to do that, let's go and create a func for that. And let's create a func. Let's copy this and say get by date handler. Okay, so the first thing we need to do is get the date which is passed through our route. And how do we do that? So to do that, you would say date colon equals to, we can use the MUX library, MUX, how do you say it? MUX dot was method, and we can say R as the request. So remember, R is the request, and we pass R, and we say the template name date. So that's the name we set as what's going to be in our route. So that's what we refer to here, and we say date. So we get the date. And so now we need to get the weather forecast for the particular date. So weather forecast, and we need to use the found. So it returns a couple of values back. So we can use the weather forecast dictionary. And it's of So that returns the value and also whether it found or not. So actually we don't need this anymore. Let's delete that. And if we can say that if found, we can set we can return the weather forecast, and we should also set the content type as this. And if it's not found, we can say w.write header, and we can set the status as http dot, we can use the status not found. And that's pretty much it. So that's pretty much it. So let's assign this to our handler. So instead of get all, we're gonna say get by date handler, and this is also an HTTP get. Let's try. Let's see if it works the first time, this time around, and run it again. So let's pick this date, and we pass it in our route. Here you go. That's get by date. So we have done. So it's 2 out of 3. So we have done get all and get by date, and now let's do a post. So to do a post, let's copy this method. In Golang, now you already get the idea how this is going to work. So you, instead of HTTP get, you're going to do method post, and we can create maybe a post handler. And so we need to create a handler method, and so let's copy the func title, and we called it post. And so now we need to grab, so post is slightly different because remember, for posting we need to post the value here, right? We expect to send down this. We're not going to send Fahrenheit because that's calculated. So let's say we will send it for the 10th, and very chilly. So this we need to get from the body. So to do that, so let's create an instance of our weather forecast first. So let's say weather forecast. So let's keep it there. And then then we need to get it from the request. So to do that, we basically say JSON.decoder, and we pass in r.body. R is our request, and then we say decode, and we pass our weather forecast reference. So decode, we expect to get initialized to that struct, so we pass that in, and that's pretty much it. Why does it not like it? We need to say error. So dot body. Okay, so what we can do is, okay, let's continue, and there's some issue here. Let's figure it out. If error is equal to not equal to nil, we need to we need to do something. So we have to say HTTP. So like we did here, we can do something like bad request, and we can pretty much finish the okay. And if otherwise, we can save it to our dictionary. So to do that, so all we need to do is weather forecast of temp dot date equals to ampersand temp. Actually, we don't need to say ampersand. Okay. So this wiggly line, convert out.body to, okay, so what they're saying, let's try. Cannot convert out.body to JSON decoder compiler. We have to say, okay, that's what I was missing. So we need to use a JSON new decoder and pass the request body, and then it can decode it to this instance of the struct. So that's pretty much it. So post handler, we have wired it up to our handler. Why do we have a squiggly line? Maybe the name is slightly different. It just needs to be post handler. That's pretty much it, I think. So let's start this again. And if I go this, we're gonna get a list of things. So it starts with the 30th. So let's actually copy that, and actually let's use this. So it goes up to the 1104. Let's add one more, 1105, and let's say minus 10. Okay, and so we need to do a post operation, and let's try. So method not allowed. Why did we get a method not allowed? We made a mistake here. So I put the date as part of my post. We can potentially do that, but let's get rid of that and restart that. So for post, we just need to post it to here. So very chilly. So we got 200, okay, but we can actually pass a return. We actually need to return status created. Let's actually fix that. Let's be restful. So once the post is done, we have to write. We actually have to set the response and set the status as well. And the status has to be created, status created, and we can actually write our response. Actually, we don't need to do that. Let's stop and start again. That's pretty much it. So now if we do it again, we should get a proper created status. And if I now do a get, I expect to see the very chilly somewhere. Here it go. So that's pretty much our three operations we did on our ASP.NET Web API, which we converted to Golang. To keep it simple, I put everything in that one file. You don't have to. When I'm going to check in this code into the GitHub repo, I'm going to move it to separate files to be more clear. Thanks for watching. Please subscribe and post any comments if you want me to concentrate on any particular topic. Thank you. Bye.